To solve this equation that contains a variable exponent, I'm going to use a method that I would call convenient base. When you have a variable exponent, to get at that variable exponent, it's going to involve logarithms. But before I can use the convenient base method, you want to make sure that the power is alone. A power has a base and it has an exponent. So here we have 5 to the negative 10 plus 3x. Once we know that power is by itself, if there was a plus 7 off to the side, we would have subtracted 7. But now that that power is by itself, we're going to take the logarithm of both sides. But specifically, the logarithm that we take of both sides will be the same base as the base in our power. The power 5 to the negative 10 plus 3x has a base of 5, so notice I took log base 5 of both sides. What's powerful about this is we can use the log property, log base b of b to the m power equals m. In other words, notice when those bases match, all of that drops off, and then the answer is just the exponent. So back over here at the problem, notice we have base 5, and all of that drops off, and all we have left is the exponent, negative 10 plus 3x. Okay, next we have a little bit of an issue because log base 5 of 3,125 would not be considered calculator friendly. In other words, many calculators cannot find a log of something that has a base other than base 10 or base e. So to make this logarithm I have in blue calculator friendly, we need to use the change of base formula. Specifically, when we use the change of base formula, we want to choose base 10 or base e because then it's calculator friendly. I'm going to go with base 10, and if you take a look at my formula there, I use W for the wanted base. We can make the W anything we want, so again my options would be 10 or E, but I'm going to go with 10. So I'll have the 10 in that spot. The next thing you want to notice is what happened to the original base and what you were taking the log of. Well, the original base in this case is b, so the original base goes to the bottom. It's an alliteration, base to the bottom. So the b goes to the bottom. Next, what we were taking the log of, which was x, that one is going to go on top. So let's put that in action for log base b, or excuse me, for log base 5 of 3,125. I'm going to rewrite it as a fraction. I'm choosing base 10, so I have log of 10 over log of 10. Now I have to decide where the 5 and the 3,125 go. The 5 goes to the bottom, the old base to the bottom. I'm going to bring that 5 down. And then what I was taking the log of previously, 3,125, goes up top. So I have log base 10 of 3,125 over log base 10 of 5. Okay, that can be a little tricky, so let's recap that one more time. We wrote log base 10 over log base 10. Then we took the old base number 5 and we moved that to the bottom. And then what we were taking the log of, 3,125, went to the top. Okay, everything there on the left is calculator friendly, so if you enter in the log of 3,125 divided by the log of 5, you get 5, and then the right side is still negative 10 plus 3x. Undoing the order of operations, I'm going to add 10 to both sides, so 15 equals 3x. Lastly, divide by 3, and x equals 5.